Scientist. Scientist.
Yes, sir.
Completed. Who are completed? Tell me fast. Time is going to over. Fast. Aprupa completed. How to do also I told you. Why you are not able to do it? Very simple calculation. 5 minutes. 5 minutes. Completed. Tell me minus not. Substitute the concentration of hydrogen ion 3.8 into 10 power 10. Sorry for the disturbance call came. Minus log 3 into 8 into 10 power minus 6. What I told you? Log minus log into 3.8 equals to minus log 3.8. Okay. And into 10 power minus 3. What I told you? 3 log 10. I told you 3 log 10. Okay. So 3 log 10 value what I told you and log 3.8 what I told you. Log 3 value 0. Minus 0.5797 into 3. Log 10 means 1 only, na? 3 into 1. Log 10 value is 1, so 3 into 1. What will get? 2.4. You will get 2.42. 2.42 or 2.4. It is the pH value of soft drink. 2.42 means it is acidic or basic or neutral. Tell me. It will be acidic or basic or neutral.
Acid.
pH value is less than 7 is there. pH value more than 7 is there. What is that? If pH value more than 7, basic. pH value less than 7, acidic. It is less than 7 or more than 7? Is less than 7 or more than 7? Huh? Less than 7.
Less than.
So solution will be acidic. So solution is acidic in nature. Acidic in nature. Solution is acidic in nature. Okay, thank you. Complete. Ma'am, can you continue or can I end the class?
Sir, I will be continuing.
Okay, okay.
Good afternoon, students.
Good afternoon, ma'am.
Good afternoon.
Good
ma'am.
afternoon.
Good afternoon, ma'am.
Good afternoon. Okay. PCMC students, your computer class is going simultaneously. You can join computer classes. I request you to leave this meeting and join to your computer class. Arindam Dash. Arindam Dash. PCMC class is computer class is not important. What are you doing here? Okay. So first thing, Arman Khan. Okay. Let's start with already we have lost 1-2 minutes, I guess. So I don't think that you people need recapitulation of the last portion because I think we have done a good job on that day. So today we will be now just for some question until I am preparing my setup. Just tell me one thing. What is the name of what is the main protein of thin filament?
Actin.
Good, actin. And the thick filament?
Myosin.
Myosin, right. So the pigment which is present in the myofiber or the muscle cell is called as, the pigment that is present in myofiber is called as
Myoglobin.
good, myoglobin. And one more thing, that is endoplasmic reticulum of myofiber is called as
Sarcoplasmic reticulum.
sarcoplasmic reticulum. Next, can you tell me just that what is a I band? What is I band? What is I band?
Only thin filaments are present.
Good. And what is Z band? Z zone. Sorry, H zone. What is H zone?
Only thick filaments are present.
So only Anisha and Apurupa is reading in my class. Rest are only in for an entertainment purpose, right? Only Anisha and Apurupa is seriously doing the classes and rest are only for entertainment. No response from anyone. Last
No, ma'am,
question. Yeah, tell me, Mritika.
No, ma'am, I'm just saying that I was doing.
Okay. So, where is Shomik? Shayok is there, present. Okay. Shukriti, Ritisha, Diptanshu, Akash. Okay. Then, if you, as I can say, that some of you have remembered all the things more or less, so it's better to start the new thing. So, today we will be discussing the structure of actin and thin filament and thick filament. The structures of Thin and thick filament we will discuss today. Won't you unless the school is giving you transport? Okay. What students? I am asking for reply. You won't come to school until unless you are provided with transport or what? What is the issue? Why you are not present today? Shukriti, what happened? Okay, so let us discuss today. Let us discuss today. Am I audible properly?
Yes, ma'am.
Okay, so let us discuss today. First, give a heading, type of protein in muscle cell. Type of proteins in muscle cell. Give a heading, type of protein in muscle cell. Type of protein in muscle cells. Okay. So the proteins are of two types. The proteins are basically of two types. There are two types of protein present in any muscle cells. First are contractile proteins and second one is regulatory protein. First is contractile protein, CONTRACTILE, contractile protein, and regulatory protein. Okay, contractile. Now, what are the characteristics of contractile protein? With the name only, you must understand that contractile proteins are having the power of contraction. Contractile proteins are having the power of contraction. So, the protein themselves do not, sorry, this protein themselves do not contract, but they can contract. They need a impulse or they need a force to contract. So we can write down that the protein themselves do not contract. But myofibril and muscle cell will contract because of them, but they make other protein contracts, like myofibril and muscle cells will contract because of them. Because of them. Example of contractile protein. What are the examples of contractile protein? The example of contractile protein are, where to write? Here I am writing the example of contractile protein are actin and myosin. So I know you people are having doubts, so I am recapitulating this part again. In the muscle cell, there are two type of protein. One is contractile protein, one is regulatory protein. So the contractile protein, this protein, they do not contract by their own, but they make myofibril. Myofibril means the cigarette-like structure present in the muscle fiber. Myofibril and myofiber contract. So they will stimulate myofibril and myofiber to contract. Example is actin and myosin. Next, what are regulatory proteins? Regulatory proteins, they decide when contraction and relaxation will happen. So they are the masterminds. This protein regulate when contraction and relaxation will happen. They are the regulatory proteins, or they regulate when to do what. Okay, so they are the masterminds who are telling, now you do this, now you do that. Okay, so examples, what are the examples of this regulatory protein? The examples are troponin and tropomyosin. Troponin and tropomyosin. Write down this part. Write down, because from this side I am starting. Now, when we have understood what type of proteins are present in actin and myosin, and what are the regulatory protein, what are the contractile protein, now it's time to understand that structure of the filaments. So next I'm going to give a heading, structure of the filaments. Structure of the filaments. So what type of filaments we are having? We are having thick filament, thin filament. So structure of the filaments, and this heading was this heading I am pointing out properly so that you can understand. Sorry. Okay, structure of the filaments. So first we will be talking about the structure of thick filament, and second we will be talking about the structure of thin filament. So first we will talk about the thick filament. First, we will be talking about our thick filament, or which is also known as myosin. Give a heading: thick filament. Right? So, the thick filament or myosin is made up of myosin protein. So, okay, so this thick filament is made up of, it is made up of the polymers of myosin, made up of the polymers of myosin protein. Myosin protein. Now, one thing you must understand, what is polymer? What is polymer? Can you tell me what is polymer? Anyone, can you tell me what is a polymer? What is a monomer? What is a polymer?
Ma'am, a polymer is made up of a lot of monomers.
So polymer is a chain of monomers, or polymers is a multi-unit, and whereas monomer is a single unit, right? So it is a polymer of a certain type of protein which is known as meromyosin. Meromyosin. Okay. So it is made up of the polymer of a certain type of protein, polymer of myosin. This myosin itself is a polymer. It is a polymer. So what is monomer of myosin? Monomer of myosin is meromyosin. MEROMYSIN. Meromyosin. Okay. Of myosin is called as meromyosin. Am I clear? Now, next we will be discussing the structure of meromyosin. Okay. This part I will be erasing. Write down. Okay, there is nothing to write down. I'll draw something. Hey, when you people will come, Ray? Come to school. Come to school. I promise I'll teach you in board. Okay. So let us see the structure of our meromyosin. Let's see. First, I will be using two colors here. Okay, first I'll be using a blue color and then I'll be using a red color. First, it has a snake-like appearance. Okay, then again it is having another subunit which is also wrapped with this and having this snake-like appearance. Okay, so at a glance, what do you mean? What do you see? That two snakes are wrapped with each other, right? So this is the structure of a meromyosin. This is one single meromyosin. So first, This part of the meromycin, both this part of the meromycin have on the top part of the meromycin, both of them have a ATP binding site with a ATPase. This side and this side. Acha, before that, this part of the meromycin is called as head. This part of the meromycin is called as neck, and or it is also called as short arm. It is also called as short arm. Togetherly, these two parts are called as, that is the head and the neck. These two parts togetherly called as head and neck part, togetherly called as heavy meromycin. Heavy
Ma'am,
yes, Ritika. Heavy meromycin.
and these thick filaments are in muscles.
Ritika, what chapter I am teaching? Yes, it is in muscles. Yes, you missed first few classes, so you got confused. See, muscle cells are made up of bundle-like structure, which is called as myofiber. Okay, myofiber. Suppose this is a muscle cell. You come to Ashok sir for revision. Why don't you come to me? You never come to me. You do your revision and go back. Okay, so this is a muscle. Suppose if we cut the muscle, we will be able to see these small vessels, which are known as this small structure. Anisha, what does this structure called? Rounded structure?
Fascicles.
Fascicles, good. Inside of that fascicles, again some round structure are present, which is known as myofiber, right? Inside of the myofiber, there is again round structure.
Myofibril.
So this is myofiber. Inside of myofibers are myofibril. So if I see one myofibril, we will be able to see that compartments are there. These compartments are known as come on, tell me.
Sarcomere.
Yes, sarcomeres. In the sarcomeres, some light filaments are present, some light thin filaments are present, which are called as actin filament, and some thick filaments are present in between two actin filament, that is called as thick filament. So we are talking about the structure of thick filament. This thick filament is made up of polymer of myosin protein, and now this is the structure of a myosin monomer. Myosin monomer is called as meromycin. So whatever I am drawing here is a meromycin. It is a meromycin. Right now I am drawing a meromycin.
Ma'am, এদের কালারটা কি vein আর blood vessel ওই artery মতন হয়?
Color? No, it is having a reddish structure. Yeah, brain blood vessels and মধ্যেই হয়, but to make you understand here I am drawing this red and blue color to differentiate both the things, but they are not red blue colored, they are having brownish color, or just as it's microscopic. No, they are microscopic, you cannot specifically tell their color. So as I was telling, on the top of this meromycins, there is a site where they bind the ATP, which is needed for the contraction of muscle. I really need time. Okay, so this is ATP binding site. ATP binding site, plus which has ATPase, ATP binding site with ATPase. ATPase means ATPase is a protein which break ATP. Okay, this part is known as a tail part. This part is known as the tail part. This part from here to here. Okay, I'm making a bigger square. This part is called as the tail part of. This is the tail part of the. This is called as tail, or also it is called as the light meromycin. Light meromycin. Okay, so total, like from total, this part is called as totally it is a myosin. I'm drawing this with a red color. So totally this is a myosin which has a, this is a myosin which has a heavy part or heavy meromycin, or which contains this head part only, and then this tail part or light meromycin. Togetherly they are called as, this total thing is called as one meromycin. Like from, I don't know where to where, from here to here, totally it is a meromycin. Clear? So as it is a monomer, monomer means a single unit. Monomer means a single unit. Is equal to single unit. We must see the polymer of meromycin. Let us try to draw the polymer of meromycin. Sorry, SIN. Myosin, YO. Meromycin. Okay, the polymer of meromycin. So in the polymer of meromycin, first we will draw the tails and then the heads. Now the next will bind from here, and the next will bind here and here.
It's looking like kind of a flag.
Flag?
Yes, ma'am. See, in one direction, unidirectional.
Flag, okay, maybe. Okay, so this is a polymer of meromycin. This is how a polymer of meromycin look like. Clear? So we are done with the monomer and polymer of meromycin and the structure of thick filament. So next we can jump into the structure of thin filament. Structure টাই তো হবে, এরপর আর টাইম কোথায়, অলরেডি 3:06. Okay, next we will be talking about the structure of thin filament. I'm erasing this entire slide. Okay, I hope you have taken picture or you have written down. Next, give a heading, structure of thin filament. But what I think, after 3:15 you are not having any class, so I can borrow few minutes from you to complete this particular topic. Okay, so structure of thin filament. See, the thin filament or the thin filament is made up of 3 protein. The thin filament, this thin filament is made up of 3 proteins. It is made up of 3 proteins. What are these 3 proteins? First, the first protein is a, you know the name. Tell me. Acha, before going to that, among these 3 proteins, 2 proteins are contractile protein and one protein is contractile protein and 2 protein is regulatory protein. One protein is contractile, who are responsible for the contraction of one protein is contractile protein and 2 proteins are regulatory protein. 2 proteins are regulatory proteins. What are this one protein? It is actin protein. And these 2 proteins are troponin, TROPONINE, troponin, and tropomyosin. SIN. Okay, so this actin is also a polymer. Okay, actin is also a polymer. So the monomers of actin is known as G-actin. The monomer, like thick filaments, myosin was there, and the monomers of myosin were known as meromycin. Similarly, the monomer of actin, is G-actin. G-actin, or which is also called as globular actin. You will know why it is called as globular actin. Why it is called as globular actin? When we see this term globular, what is the first thing come in our mind? Globular. When you say globular, what is the first thing come on your mind? Something which is like globe or round. So this is a G-actin. the single unit of actin or G-actin is this. This is a G-actin. G-actin. Now, let us make a polymer of G-actin. So, how we will make a polymer of G-actin? Just like this. By attaching all the G-actins together like a chain or like a pearl necklace. Okay. This is a chain of G-actin or a filament of G-actin. This structure is called as, this whole structure is called as, which is made up of a plenty of monomer actin. This structure is known as F-actin. F-actin. Or that means filamentous actin. Filamentous actin. Clear? I am telling you again. A single unit of actin polymer is known as G-actin. A single monomer of actin filament is known as G-actin. This is known as G-actin. When all the G-actins are chained and lined together, this total thing is called as F-actin or filamentous actin. Now finally, it's time to show you how this actin stay in, like what is the whole structure of actin, because previously what we saw that actin is made up of 3 proteins. It is made up of 3 proteins. One is actin. This thin filament is made up of 3 proteins. One is actin protein, one is troponin and tropomyosin. So if we are talking about the structure of thin filament, we got only the actin protein part. What about this troponin and tropomyosin protein? Now we will see that. First, this F-actin thing don't stay alone. That means, suppose this is a, let's make a chain of F-actin. This is a chain of F-actin. So a chain of F-actin is always combined with another chain of F-actin. Like this, they are intertangled or spiraled. One is attached, one is attached to another. Okay. So now we got 2 F-actins. Now these 2 F-actins are again covered or spiraled by another protein which is known as tropomyosin. Okay, so tropomyosin protein wrap this F-actin complexes like this. Okay, am I clear? First, up to this part, am I clear? That first, what we saw, that there are some actin proteins. These are the actin proteins. This is the G-actin, and togetherly this G-actin is forming F-actin. Now 2 F-actin film, 2 F-actin, this is 1 and this is 2. They first intercoiled together. On the top of that, another protein which is known as tropomyosin protein is attached. Now, on the top of tropomyosin, some proteins will be sitting so that tropomyosin does not move from its place. This is troponin. Troponin protein is having 3 units. This is troponin. We are almost at the end of our discussion today. Just the functions of these 3 things and we will be done. Let's do the pointings. First, this is F-actin, F-actin. This is F-actin. F-actin, right? This red thing is the tropomyosin. Tropomyosin, and this is troponin. Troponin. Clear up to this part? Tropomyosin, troponin. See, now what is the function of tropomyosin? What is the function of tropomyosin? First, if you remember the structure of the polymer of myosin, that is the structure, like Anisha told, it's more like a flag. The head portions were having ATP binding sites. ATP binding sites. This portion always try to attach with the actin filament, this filament. They always try to attach with this filament. And whenever they get attached, we contract, muscle contract. But see, is it always important? Like muscle contraction is good, but it is always good. Suppose now I am teaching you, suddenly my hand muscle contract and I am like Pushpa, okay, and one shoulder up. It's a very weird thing. We don't want that random contraction. So this tropomyosin is present there to cover the actin filament. The tropomyosin is present there to cover the actin filament. So what is the function of tropomyosin? Where I'll write function of tropomyosin is to, acha, here I am writing, suppose this is a actin filament. So tropomyosin usually cover this actin filament like this, the active side of the actin filament. So actin filament, actin monomer or globular actin or G-actin itself is also having a site which is myosin binding site. Myosin binding site. Myosin binding site. Okay, it's having a myosin binding site. Who always want to bind with this myosin. So now, this is the villain. This tropomyosin is the villain between two hero and heroine. This is the heroine and this is the hero who are only trying to get closure. And now this tropomyosin is there who is preventing. No, dude, you don't do that, else the muscle will be contracted. So what is the function of tropomyosin? Write down. Tropomyosin prevent or hides, tropomyosin hides. For now I am erasing the structure of this because you understand what I try to say. Hides, tropomyosin hides the site of actin, or tropomyosin hides the myosin binding site the myosin binding site of G-actin. Right. So now we got we understood the function of tropomyosin. Last thing to understand is this structure or troponin. Right. So troponin, as I told, is a 3-unit structure. Troponin is a 3-unit structure. 1 unit, 2 unit, and 3 unit. These 3 units are having 3 names. One is called as TPI. TP for troponin. TPI. One is known as TPT, not your DPT, TPT. And third one is known as TPC. TPC. So function of TPI is inhibit actin myosin binding. Actin myosin bond. AM means actin myosin bond. Just same function like tropomyosin. TPT, it binds with tropomyosin and keep the troposin in proper place. Its function is to keep tropomyosin in proper place. Thirdly, TPC bind with calcium. This function we will discuss in next class. Binds, but you for now write down, binds with calcium. Binds with calcium. So I am giving you a last idea about what I just said. Just a quick recapitulation. Structure of myosin you understood. Structure of thin filament, or the thin filament is this thin filament is made up of 3 proteins. 1 contraction protein, which is actin, and 2 regulatory protein, which is pro-regulatory protein are troponin and tropomyosin. Now, this tropomyosin, this actin is also a polymer. The monomer of actin is called as G-actin or globular actin. When these monomers are lined in a chain, it is called as F-actin or filamentous actin. Right? When the thin filament form, these 2 F-actin are intertangled with each other, which is again wrapped by tropomyosin protein. And on the top of that, troponin proteins are present. Function of tropomyosin is to hide the myosin binding site of G-actin. Myosin always have a myosin binding site of which the tropomyosin hides. Right? Now, what is this troponin? Troponin has 3 units: troponin I, troponin T, troponin C. Troponin I inhibit actin myosin bond just like tropomyosin. Troponin T keep the tropomyosin in proper place, and troponin C binds with calcium. That's all for today. Okay? Anyone having any doubt? Come with that.
Ma'am, you have not told the function of T-tubule.
T-tubule. Next day, when we will be understanding the neuromuscular junction, how the muscle contracts. Still we are in structure. We have not started the contraction part. When we will start the contraction, how muscle contract, that time we will have a clear idea that what is the function of T-tubule. Okay. Don't worry, Anisha, I'm not going anywhere without telling you T-tubules. Anyone else from today's topic? Alicia, any doubt? Alicia, are you there? Anurag, any doubt? Arey, the students are sleeping. Entire time I was talking all about alone. Shayanti,
Yes, ma'am.
any doubt?
No, ma'am.
Mritika?
No, ma'am.
Okay. Anisha?
No, ma'am.
Shomallo? Not even there.
No, ma'am.
Okay, present. So good. Alicia, Aditya? Aditya, not even there. Aishik? Aishik, you are not attending classes. You are not attending, okay. Okay, good. Next, Shayok, any doubt? Nikita, any doubt?
No, ma'am.
Okay, Diptangshu, Rishita?
No, ma'am.
Chandan, Shukriti, Srishant?
No, ma'am.
From 3 people, 1 response. Okay. Thank you, students. I'm sending you the classworks. Thank you all. All the best for Saraswati Puja. Anyways, you are not getting any holidays. Okay, come to school. Bye.
Thank you, ma'am.
ছুটি থাকবে না
Thank you, ma'am. Thank you, ma'am.
না থাকবে না কোনো ছুটি।
अरे नेहा कहाँ है?
शॉपिंग पे गई है, आ जाएगी।